All right, today we are doing the 20 game challenge. That doesn't mean we're building 20 games, we're building one game. What is the 20 game challenge? It's essentially a list of games, and you make those games, but the list is organized in such a way that they get harder and larger as you go. And it's just a way of teaching game development by kind of copying these games. And it's this website, you can see it, you can Google it, 20 game challenge. First cab off the rank is Pong. So we're just going to jump into it. This is number one. So you can follow along, you can build it yourself, and basically learn game dev by just making these games. So we're obviously using the Godot engine, as I think it says. But let's do it, dive right in. So I'm going to be using a 2D scene and we're going to get started. So the first thing that we're going to need, I'm just going to jump straight in and build a paddle straight away. But I'm going to have this as the world scene or something like this. Let's just save that. But then I'm going to build a paddle. Now what is a paddle? And what does a paddle need to do? It's going to need to move. So we're going to need to control it with the input keys. Well, one of the paddles, but the other paddle is going to be controlled by the AI. So it's going to have to be a shape that we can control. So I think we're going to not use physics for this, but just use collision. So if you're wondering what the difference between those two are, like physics is the actual physics engine, where if a collision occurs, the physics engine computes what happens. Like if two things touch, then it computes the bounce for you. But in Godot, you can just use the collision engine where it detects the collision and then you say what happens. I think because Pong is so simple, I think we're going to do it that way. So that means in 2D, we're going to be using an area 2D. Basically, it's kind of that half of the physics that detects, but it doesn't do anything. So this is my paddle scene, and the root node is going to be in area 2D. And you can see we get this warning. We're going to need a collision detection object. So what is that? That's going to be a collision shape 2D, and we also know we're going to need like a mesh so that can display it. So let's display this so we can actually look at it. The mesh, we can just have a quad mesh. That's very tiny, but we'll fix that soon. The collision shape is going to be rectangle. Nice. So we've got tiny mesh, big collision shape. So these obviously need to be the same size. I don't know, how big is this going to be? 20? Oh wow, wait, I got it right. Incredible. Okay, so let's save this as our paddle. And obviously it's gonna be wider. You all know what Pong looks like, right? So we want this, it's not a square. So I immediately kind of got it wrong in a sense. What do you reckon the Y is gonna be 100? Does that look like a Pong paddle? I think it's probably fine for now. So we've got our paddle, and that's already going to collide, or not collide, but it's going to detect collisions of anything going into it once we set that up. Cool. Well, let's pull some paddles into the world. So I'm going to have one here and one here, and we've got these two paddles. Maybe let's just do one for now. That's probably a little bit overzealous. And we're going to call this one, let's say, the player paddle. And what do we want to do? Do we want to collide the ball or do we want to move it first? I think I want to collide the ball with it first rather than moving it, because I'm not sure how I'm going to do the moving code yet. So let's make a ball. And we're going to make everything in area 2D, I think, just so we can handle all the physics code ourselves. So let's make another area 2D. This is going to be the ball, which means, yeah, we'll do the same thing. So we'll have a mesh, but 2D meshes in Godot, like there's no circle. Sound off in the comments if you know how to actually add a 2D mesh, but a sphere I think works fine. So this is also going to need a collision shape. Obviously a collision shape has a 2D, circle shape 2D. Again, yeah, so this mesh is like actually like a 3D sphere, but rendered in 2D, which doesn't feel great, but there's no circle in the list, so we're just going to make it work, and that's going to be fine. So, what is this? This is just a ball. We can save that as a ball. Okay, let's pull the ball into the world. Okay, we made a ton of progress already. Now the ball's going to need some code, so let's add a script. Excellent. And basically we just want the like physics process. So in Godot, you probably know already, there's the process and the physics process functions. The physics process function, it runs once every physics tick, whereas the process function, the one that looks like this, process, this runs every frame. So every time the frame is updated. Sorry, this is not attached to, I gotta do something quickly in the IDE. Sorry about this. Okay. Nice, now we're connected. We don't need that one, we're going to do it in the physics tick. The physics tick is supposed to be consistent. It doesn't depend on render times. The idea is that the physics process, you know, if you set it to 30 frames a second, 60 frames a second, the idea is that it kind of stays consistent throughout. Whereas you might want to be rendering more often to make things look a bit smoother. Cool, so we're going to be doing it in here, and let's just change the position every single tick and just see if it's working. So this, I don't know, change it by 1. That's not going to work because this is actually a vector, so we need x and y coordinates here. So let's change the x coordinate, not the y coordinate. I think if we run this, it's already just going to move. How are we looking? Look at that. We've got this running already. Okay. I want to press escape to exit, so I'm just really quickly going to write is that worth it? Yeah, let's just, when I open this, if I press escape, I want to quit the game, and that's just like a handy little thing that I like to do. So let's just put that in here. Action, what is it? Is action just pressed? That's right. Is it UI cancel? I think that's the escape, right? And then we just call something like get tree.quit. I think that already just works, right? And now we can quit with escape. That's just like a handy little tip. Okay, let's move the ball towards the paddle, right? Maybe a little bit quicker. So now what we want to happen is when the ball hits the paddle, boop, right now it goes straight through. So we need to fix that. We want it to actually hit. So the ball, yeah, the ball. So the ball should be the one registering, because the ball is the one that Yeah, sorry. So the thing that I'm thinking about now is where does the code live, right? So is the paddle hitting the ball? So in that sense, like we write code in the paddle. In a sense, yes, but in a sense, it's kind of the ball that should get hit, right? So like the ball should be in charge of its own movement, and the ball can kind of detect when it's hit the paddle, and then it can change its own kind of velocity. So I think we connect this one up, right? So this signal, this should run whenever it kind of hits anything else. So we're just going to print a statement to see if this is working. So ball got hit by something. And then that's something we can print that out here. You can see as an input into the function. Maybe we should make this a bit bigger. Whoa, that's the opposite of what I wanted. There we go. So if the ball hits the paddle, we should see down here, ball got hit something, player paddle. So we've detected the motion. So that area, what do we do once it gets hit? So we kind of want to know what it is. So the paddle, maybe let's call this paddle. Yeah. Okay, so what I'm thinking through right now is that when the ball hits the paddle, we want it to bounce and go to the right. But it's the opposite if it's the other paddle, and if it's the top, you know how Pong works, there's a barrier at the top as well as a barrier at the bottom. And so we kind of want to encode that information in the object that it's hitting, and then it can get that. So one way we could do this, and there's kind of like a little bit of a, we could kind of just put a variable on this paddle. This is a little bit of a funny way of doing this, but what we can do is we can have a variable here, like hit direction or something, and that can be like a vector 2, and it can be like the direction. Is it this way? I think so. So this paddle should have this hit direction. And so when we have two of these, another one over here, we've got this one and the hit direction is 0, 1. And this one, we can have the hit direction be -1, right? And then the ball, the area should have like hit direction. Let's just print that it exists at all. Let's just make sure we're like grabbing that variable and that it exists, because we're not actually checking that it does exist. So we hit direction is 1, 0, and then if we go the other way, let's just make that 10 and fly off to the right, we can hit the other paddle. The hit direction is -1. So this variable here, area.hit direction, this tells us like what our new speed is supposed to be. So we can have like, let's just have a variable for like velocity, and it's like this, right? So we just update the velocity, we hold the velocity, and we update the position with the velocity, and then we hit direction times some sort of like speed have some kind of current speed, because balls obviously can get faster as well. Let's maybe do something like this, and this is just like a scalar, right? This is, let's just make this 3. This looks good, right? So now, boop, it went straight upwards. Why did that happen? Okay, so the velocity should be, so the position plus equals velocity, and the velocity gets set to, why did it go straight up? What happens if it goes and hits the other one? Wait, it went down. Oh, because we got we got this wrong. Okay, so the paddle, this is X and Y. We've set it. Oh my goodness, that's amazing. So it should be the X, not the Y. And so in our world, this should be, oh hey, undefined. What's going on? Do you do Godot programming? So this should be, Y should be 0 and X should be, is it -1 on this one? And on the player paddle, X is 1. Okay, so now it should go, bam, and it hits. So we've got the physics working. And now it hits. Look at that. We're basically done. Yep, I'm a Unity game programmer. Nice. Tell me about some of your projects. What are you working on? So we've got the bumping. There's a couple things like speeding up and all the rest of it, but let's work on actually moving the paddle now. So we're going to add in the input map, we're going to add some buttons. So this, we'll just call it up. That's probably fine, right? Call it down, and then I'm going to bind some keys. So for up, I'm just going to use W, and for down, I'm just going to use S. But in Godot, you can use this input map to map multiple buttons to the same, you can bind them to the same input. That's really nice. So you can put like the arrows, you can put the up arrow here as a secondary trigger, or like not even secondary, but like another trigger. So W and up kind of do the same thing in the game. And then you don't have to, every time you use them in code, do like, kind of check for both every time. You just do it once, and then you bind it to up, just this one upward. So that's really cool. So now we've got up and down sort of set to those keys. Basically 3D multiplayer shooting game. Very, very cool. Where are you from? I'm from Aussie, Australia. Can you hear the accent? Now we just need to grab a handle of those. So in the paddle, so this is where we need to have a distinction between the player paddle and the other paddle. So one way that we could do this is we could do some sort of like inheritance magic, but I think actually I'm not going to fuss around with that. I'm just going to get rid of this other paddle entirely and then just build 2 separate paddles because they're so, because it's very simple. So we're going to do on physics process. So we're going to grab the, what is it? Is action pressed. So when you're grabbing keys and doing input, there's actually a pretty big difference between the different ways that you can detect input. And what we are doing now is every single physics tick, we're checking whether or not the button is pressed, which is quite different than reacting when you do get a hit, or checking at the start of a frame whether a button was pressed since the last frame. So I guess they're the three sort of big, like, main ways to do it. And what we want is smooth movement. So if someone's holding down a key, for every frame, every physics frame that they're holding that key down, we want to be moving the button. It's not a case that we want to just react no matter where we are in the code as soon as they press to kind of do something. And it's not the case that we're checking for, is this the first time? It's just, if the key's down, let's move. We really just, so this is where we check, is up being pressed? We can literally just change the position right here. Let's just set up like a constant for the speed. So constant to check the, oh nice, I'm from India. Very cool. How long have you been doing game programming for? And what are your thoughts, Godot versus Unity? You've done some Unity stuff. Keen to hear. So if, yeah, so let's just have like an up speed or something like this. We should do it in const case, up speed. And that can just be, this has to be a vector 2 because it's a direction, because we're adding it to the whole position. So the x is obviously going to be 0, and the y is y positive upwards or downwards? I don't know. We're about to find out. I think it's actually like this, right? But as we saw, one is a little bit slow. So let's just do it. Let's do it down. And yeah, that's fine. And so this should be pretty obvious what I'm doing. So now we get a really interesting thing, which is if you're pressing up, then we add the up speed. If you're pressing down, then you get the down speed. What happens if you press both? So if I have an else here, then we have an interesting situation, in, what is it? elif. So if it's else if, we have an interesting situation where the down is ignored if they're both pressed and you just go up. But if you write it like this, then they cancel each other out. There's another way to do it. There's like a built-in function. What's it called? Like get movement access. Not going to talk about that today. This is fine for now. This I think already works, right? Nice, yeah. So when I press W, then it moves up. Unity better because it has ECS system on it. That's the entity component system, right? Are you gonna convince me that it's better in the comments of this video? Why is it better? Okay, so firstly, that feels awfully sluggish. Let's speed that up. I don't know, 9. Welcome to game dev. So type around a number, see how it feels. That feels pretty good. It feels pretty good. One thing I want to change is this background. It's so ugly. Can we get, you could always spell stuff American, color. Background, what is it called? Viewport, transparent background. Isn't there like a, you know what? We're building a fat mesh and we're putting it in the background. Chord mesh. Cool. There we go. That's still not even big enough. Yeah, lovely. Wait, how do I make it? Material. New shader material. Wait, I have to write a shader? Okay. world background. We're just gonna write a real quick shader. Where are you? Vertex, no. Fragment, no. Let's just quickly, this is a little bit too advanced for what I'm going for here, but we're just gonna make this, is it vec3? We're just gonna make it black. It's not black. It says it's black. Spatial. We gotta make it a 2D shader. (2D) shader has a variable called color, and it's supposed to be a vec4. That says black. I really thought this would be a lot easier. The material is black. This is a waste of time. Okay, so this is what happens when you try to do something you don't instantly know exactly how to do. It's need a texture. So we're just gonna keep moving. Get rid of this. There's a way just to like change the background there, right? Surely. It's just like a background color. Color. Hey, look at this. Okay. Now it doesn't look so gray and drab. Look at that. Now we got a nice black. There we go. I'm glad I didn't write a shader for that. Let's get rid of you. Okay, cool. So we are we're looking good. We can move the paddle. We've got physics. We can move. Ball goes away from us, so you know we're winning every time. We've got no opponent. But the next thing is to get an AI to start moving. So as I mentioned, I'm just going to write a completely different object, like a new scene. This is also going to be in area 2D, so this will be able to detect when the ball hits it, or more importantly, the ball will be able to detect when it hits this paddle. So this is going to be the like AI paddle, and this is basically going to have the same things. It's going to have this collision shape and this mesh here like this. AI paddle, we can bring one of these in to the world, and you can sit here, and you obviously are going to need the AI paddle is going to need a script, and it's going to be similar to this. It just needs this line, right? Yeah, so it's going to have this direction, and we can have that as a -1, and so the AI paddle hits to the left, and our player paddle hits to the right. Boom. Okay, so the speed obviously dropped there. Very nice. We're playing Pong, look at that. And I missed it and it goes through. Cool. So there's a couple stuff we still need to do. One is when you hit the ball, the direction needs to be proportional to where you hit it, right? So when the ball hits the top of the paddle, the ball needs to go a bit to the top. So how do we do that? Obviously in the ball script. So we can compare, it's going to be in here, so area, the area dot position is going to be like less than or greater than the ball position. So the difference between these two is going to determine how, like, where our x is. So the area position minus position, we actually just want the, like, the y values of these, right? So the difference between these, if the, if the paddle's position is lower than the ball's position, then the ball should go up. And the more lower the paddle's position is, the more up the ball should go. But why is a negative in Godot? So, like, negative is up, right? So I'm going to use the incredible technique of guess and check. So we're just going to basically add this to the y velocity. Let's just call this, like, y velocity is just equal to this. And then our velocity dot y plus equals the y val. So this might do the opposite of what we want, or it might do exactly what we want. Goodness, what on earth happened there? So let's do a little bit of a debug. Area position, area pos, and let's get the ball pos. Yeah, let's see what this looks like. So we hit that. The area position, so they're quite different. They're not aligned at all. The ball and the paddle are both centered. Why? Is it because it genuinely, so if we put it like here, is that genuinely how the maths works out? Yeah, interesting. Okay, so we've got it negative, it's round the wrong way. So this should, should come around there. And it's also way too strong. So this should be divided by like 10 or something, hard to say. So now, that looks pretty reasonable. And if we do it like close to the middle, it should pretty well straight. Whoops, I forgot to move it again. And if we put it up here and it hits down, and it hits down, that's pretty good. And now we can play, boom. Well, that didn't work. It's kind of drastic, isn't it? So we can try and do one of these extreme edge touches. Very cool. Nice. So thinking, so the next thing to probably do, let's just try and keep everything in bounds. Let's add some wall pieces. So this is going to be something very similar to the paddles. So we're going to add an area. Let's type in here. This is going to be a wall. We're going to have two of these. It's going to be super similar, but a very different shape and size. So you are going to be maybe more like 20 and 10,000, right? That's fine. And this is going to be the top, like ceiling. We can save you as a wall. You're going to also need a script. And you're going to need one of these so we can say what direction you're supposed to be doing. So when the ball hits you, what direction will that ball go? So either 1 or -1, and we can change that. So in the world, we just bring in some of these walls. Let's just put one at the top and one at the bottom, and then the one at the bottom yeah, here we go. The one at the bottom, we make this -1. Okay, so now it should be able to bounce off this wall. The paddle can still go through the wall. Boom. Boom. You see the bug? It sets the direction. So when the ball hits the wall, it's losing its x velocity. So that's because we're making some assumptions here about the paddle. So we need to have some sort of type. Yeah. We're just going to do it as a variable. So this is just going to be like variable. Yeah, so like the real kind of way to do this would be with inheritance, and you would have like a type, you would have like a wall type and a paddle type that could inherit from some sort of like hittable object type, and then you would know for certain that that is something that you can hit, and then once you hit it, you check what type it is from there, so you would know for certain that it has some sort of variable that has like, we're not going to do that. I'm not going to explain it because we're not going to do it. We're just going to say, we're just going to make sure that we have this variable available to us using the magic of GDScript. So this is just going to have a, I'm just wondering if we even need this, right? Because maybe we're just, yeah, we need to know whether or not to do this calculation. Do we need to do this calculation? And yeah, so we're gonna have like a variable like is paddle, right? And then on the paddles, we just have one of these. And then there's like an AI paddle script as well, right? Oh wait, U is supposed to be true, but then the wall script is supposed to be false. Okay, so now that we have that, we know in the ball script if area dot is paddle, right? So if it's a paddle, this is what we do. Otherwise, we just basically the velocity velocity dot y equals hit direction times speed, and we don't change the x. I wonder if this works. So you're gonna hit it against the wall and it crashes. Invalid assignment of property type key y value vector 2 and base vector 2. What are you talking about? In ball 15, what is ball 15? Velocity dot y, area dot hit direction. So this is a vector 2 and it's trying to assign to that area.hitDirection.y. Okay, well, let's make sure we shut that. Okay. Now it's not going to crash this time. So let's see if that bounces as it's supposed to bounce. Hey, ooh, hello. That was a little bit fun. Both of those collisions went incorrectly. So the current speed. I see what's going on, because we are taking the current speed, which is the total speed. I think there must be an easier way to do this, but this is, so what we've done is we've taken the entire speed and we've put it into the y direction rather than only the y component of the current speed. So rather than, yeah, so we actually need, whoa, what was that? We actually need the velocity's y component. So that first thing that went wrong there, I think we can fix it like this. That looks pretty reasonable. And now the paddle is going the wrong direction. So the player paddle, x is 1. So if it is a paddle, the velocity area to hit direction times current speed. Why did it go? So the AI paddle hit direction is -1. The player paddle is 1. That is a little bit strange though, right? That is a little bit strange. So maybe let's just do a little quick debug. Hitting paddle, and what do we want to do? We want to know the area dot hit direction, right? And let's just start the ball off going backwards. This will just help us test a little bit faster. Oh wait, negative. What are you talking about? Ooh, what's going on? The current speed. That is interesting. I wonder if those need to be the same. So we go there, and it just passes straight through. And nothing has been printed, which means the paddle, the paddle is false. Oh my goodness. Oh, that is unbelievable. That is unbelievable. Okay, so now we can hit, nice. So we've got a lot of the components going. This is going very well. So now all we need is, well, a couple things, but the AI needs to try and track the ball's position. So we need to build an AI that can actually like somewhat half decent play. And there are a couple of different ways that we can build this AI. One is, it's actually very, very easy to make it perfect, because we can just set the Y position of the AI paddle to the Y position of the ball, and we'll basically never be able to beat it because it would just play perfectly. And that's really, really easy to write. It's this funny thing in game programming that it's almost always easier to write an AI that is unbelievably good, way too good, or really, really bad. It's hard to get that, to write an AI that's the right level of difficulty. So let's basically just start with that though, because we just need to make sure we've got the ball's speed or the ball's like y position in the script of the AI paddle. So the AI paddle needs access to the ball. So how do we want to do this? One way we can do it is we can just set a reference. We can just basically, in the AI paddle, we can have like some function called like set ball, and we just basically give it a reference to the ball, and we've just got this like ball here, and then in the like parent on startup, wait, what is it, ready? Nope. We can just call this AI paddle. What is that dot doing? AI paddle dot set ball, and we just give it, what do we call the ball? It's called area to do. Well, let's call this ball. There we go. And then in the physics process, we can just say that position.y equals ball dot position.y. And so that should basically just track the entire, yeah, this should be basically unbeatable. But it's also not very good because it's just going to, it's always going to hit it back straight. Oh. That wall didn't work. Which wall is that? This wall, hit direction is 1, and this wall, hit direction is -1. We don't need that anymore. So if it is the paddle, oh wait, is the wall, has it been set? Where's the wall? This guy. Direction 1, but its export is paddle false. Huh. So is the problem that area dot hit direction hitting wall? Let's just have a look at that. So we hit the top wall and it went straight through, and it's hitting the wall, and the hit direction is 0, 1, and if we hit the bottom one, 0, -1. So in both cases, it's just going up. So the velocity is equal to the hit direction y times the current velocity y. Oh, that doesn't work at all. This needs to be the absolute value. And so yeah, and now that's gonna work. Yeah, so to explain that, the absolute value, yeah, so the top wall, is that right? The top wall has a value of 1, which is down in Godot. Negative is up. So the top wall has a value of -1, and you multiply that by the existing y velocity. So whatever y velocity it has coming into that collision, we times it by times the absolute value by -1. Great. We are unbelievably close, aren't we? This is going well. We just have a so we can actually play now. We can whack it down. The problem is the AI is too perfect and the ball doesn't get faster. So every time we hit the ball, we want the ball to get faster, and then also the AI should be not perfect. We need to make it not perfect somehow. So we could, there are a lot of ways to do this. How do we want to do it? There's a lot of very complex ways to do this. What do you think? So you can cap the speed. You can cap the speed. You can, so that it is kind of trying to catch up, like do some sort of tween, right? Like rather than create tween. I don't know if I want to use a tween. So yeah, we could just write one ourselves, right? So whatever we could just move towards it. Yeah, so like the difference between, well, what is going on? Gap. So the difference between the position of the ball and the position of the paddle is some sort of gap. And then we could say, we could like clamp the gap. So the value and then the min and the max. So the clamp of gap. And we could say you're not allowed to move more than 3 or something like this. So we say like your max speed is 3, and then we do position dot y plus equals gap. But wait, the clamp returns, it doesn't edit it, right? Yeah, it returns. So we get like, you bump one button and it messes up your whole idea. Okay, so does that work? It can't move faster than 3, and it's going backwards as well. So it should be, yeah, there we go. So it goes this direction. And so now it should be capped at a speed. So yeah, it's trying to get there, but it's pretty limited. That's maybe a little bit too weak. So the difference between the ball's position and its position is the gap. Oh, but it can't move. This needs to be -3. I just like lost its entire ability to go down. So now it's going to move towards the position, but it's going to be clapped. So it made it in time. So we could make it even slower, or we could just move the ball faster, right? Just make the game a bit more dynamic as well. Let's just put this the player paddle. Whoa, that is not what I meant at all. What selection option do I have here? Okay, so let's yeah, so now it's going to be like a little bit bad at the game, right? Yes, incredible. So this speed, the relationship between this clamp and the speed of the ball is going to be basically determining like how good the AI is. So if we set it like something reasonable, like 5, it should be able to play at this ball speed, right? Like it should be able to return that yeah, it's done a perfect return there. But it doesn't, yeah, look at that. So it's hitting it pretty well in the middle. So if we go for a bit of a bigger shot, it's still getting there just fine. So this looks pretty good. Now what we need to do is make the ball go faster over time. So every time the ball gets hit, we just increase the current speed, which is pretty easy, right? We just plus equals, let's just make it, oh wait, does current speed go negative? Does it swap between positive and negative? No, it doesn't, right? Let's just make it a massive number just to make sure it's actually working correctly. Yeah, that's moving. Yeah, perfect. So if we make it like 0.5, how's this for difficulty? This is looking pretty good. So we can kind of make it work. Yeah, so it never tries to hit it anything other than straight. Yeah, so it's like, so it's playing like extremely defensively. So it would be nice if we got it to like have a little bit of flair, right? Like we want it to like try and do like not a trick shot, but like, you know, an angle shot. Like if we put some sort of constant here, right? If we put some sort of constant here, it would always try and hit like with the top of the paddle. Yeah, so now it's going to try and hit in the top. Let me try and hit it down. Yeah, so it didn't quite get there, but it's always going to try and hit in the top. That's cool, but it'd be more interesting if it mixed it up, right? So let's just like quickly add in a random number generator, and then so we need to know every time it hits the ball. So every time the ball hits it, it's gonna call like this some sort of like random reset, right? Random like target reset, and this is gonna do something, but basically, and then we're gonna need like a constant to take care of the actual amount. 5 was like not quite enough, right? So like constant, like the amount that it's trying to do a trick shot, like the distance from the center. Let's just go as like trick shot size, and we could like scale that up throughout the game as well, but that's just going to be like a float of 10.0. Wait, we need that, so you need to be this. So the trick shot out 10, yeah. So, but is it going to be positive or is it going to be negative, right? So this trick shot size is actually going to be multiplied. Order of operations, everything's fine, right? This is going to be multiplied by like, what is this, like trick shot side, right? Yeah, so this, whoa, trick shot side, this is just going to be like 1 or negative 1, right? And every time we reset, every time we hit the ball, we're going to either change between wanting to like hit the top or hit the bottom. So we just need RNG dot, what is it? Rand I. What does rand I do? Returns a pseudo random number of 0 and whatever the hell. So what is that, max int or something? Nah, we need just 0 or 1, right? Random range, where are you? Between from and to inclusive, right? So we just need 0 and 1. And we are just setting the trickshot side to that. So we call the reset at the start, and then we just need to make sure the ball is paddle true, is AI equals true, and then in paddle is AI is equal to false. And so once we've hit the paddle, if area dot is AI, then if it is an AI, then we do the target reset. And so then that way it'll try and do a trick shot up or a trick shot down. It'll be randomly generated every time it hits the ball. Now let's see if any of this works. So I hit it up, and it's really hard to tell whether it was trying to hit it up or I'll try and hit a straight one. I think we're going to need to check if that is actually yeah, so let's do trick shot reset and trick shot side. This is, I mean, this looks right. Yeah, I mean, it looks correct. This is a bit big. Trick shot reset 1. Trick shot reset 1. Trick shot reset 0. Oh, it's 0. Ah, 0. It needs to be -1, not 0. That makes sense. So we could just make this -1, and then a third of the time it tries to hit it straight, a third of the time it tries to hit down, a third of the time it tries to hit up. That's quite cool, actually. And then is the trick shot size not dramatic enough? Like, what if we made it 20? All right, I'm hitting it up. You're hitting it straight. So it's been reset to 0 again. Now it's been reset to 1, so it's going to try and hit a more dramatic up. Yes, yes, okay. So maybe is 40? I mean, how big is this thing? How large is it? What is your size? The size is 100, so 50 is the max. So it could go, yeah, so 45 is like really trying to play on the edge. So it's trying to do, yeah, there we go. It's trying to play the game now. Hey, look at this. Yeah, it's really like aiming for that, but it is possible to miss. Like if it gets too fast, then it is going to. Oh, I'm also a little slow. Hey, nice. That felt good. That felt nice to play. Okay, so we are gonna need to do like point detection now. So we're gonna need a new area which is going to detect when it's gone kind of beyond the field of play and someone scored a point. So that's going to be a new scene, and it's again going to be an area. So this area needs a collision detection. Wait, what's going on? Oh, you need a collision shape 2D, and you're going to be a rectangle, and you're going to be quite a large rectangle. Not really any point to dialing that size in too precisely, but basically you are, what are you? You're like a end zone or something. And that end zone, let's just save that. That end zone's gonna have some sort of variable in it. Let's export it so we can have access to it. So the end zone is going to be determining like whether you're left or right, like who gets a point. So it's like which player are you basically. And we'll just set it to like 1 or 0, right? We don't need to set up some enum. So like one way you might want to do this is actually set up a global enum, and then you'd be able to track like left versus right. We're just going to do 0 and 1 for now. That's fine. It's all just 0 and 1 under the hood anyway. So, so this guy, player, and so the end zone is going to be for one player or the other. So let's bring some end zones into our world here, and then another one here, and this second one is going to be, so player 0 is on the left, that's me, player 1 is there on the right. Very, very nice. So we need to register the end zone if it is paddle. Yeah, so now we've got 3 different things that the ball can hit. It might be just about time to set up a config, I think. Probably could have done this earlier, but we're going to do a little bit of refactoring. So we're going to have, not config, what is this? This is like types.gd. That's fine, it's fine, it's fine. So in here we're going to have some sort of like enum. We want a class name, right? Class name types. Oh, that feels like I might be overriding something, but we'll see if it works. And then this is going to be like an enum that is a list of everything that the ball could feasibly hit. And so a good name for that would be like hittable objects, type of object, types dot object. Hittable type. Do you have like a capital? What is the syntax of enums? It's just like paddle, wall, end zone. Is that right? So instead of is paddle equals true, we have var type equals, and that's going to be the like types dot hittable dot paddle, and that is broken. Is it just one of those things where it hasn't like refreshed yet? If we like run the game, get rid of this script. Types is not declared in the current scope. Cannot infer the type of type. Huh. I feel like you can infer though, right? Anyway, so now the paddle, instead of being like is paddle, we're gonna have like a type for paddle, and an enum type. That's cool. And then the wall is also not gonna have this. You're going to have wall. That's pretty good. And then the end zone is gonna have, end zone. So now the ball, I'm gonna go to the ball file. The it's not if area is paddle, it's match area dot type case types dot hittable dot paddle. Whoa, hey, and then this is types dot hittable dot wall. And then we have end zone, and then if you're end zone, we need to give someone a point. So we need to be accessing area dot player, and we need to have like the score visible. So before we do that, let's put the what is it called? A label. We're going to put a label on here. Whoa. Yeah, nice. We're going to have a label. And that's going to be the score. It's going to start out at 0. And this is going to be the P1 score. We're gonna have, hey, I said copy paste. What are you talking about? Copy paste. All right, and this is gonna be player to score, and you're gonna go here or something. I probably could have got this just a little bit bigger. Label settings. New label settings, line spacing, font size. Here we go. How does this look? 40? That's about right. Let's get one of them. Let's get another one. P2 score. Okay, so in the world, we need to connect the end zones. So the end zone has access to, yes, we've got P1 end zone. Hold on. The P1 end zone is the end zone that detects behind P2. So this is the P2 end zone, and this is the P1 end zone, because that's who's responsible for updating the score. So the end zone, the P1 end zone, we can like have some function like set label or something like this. Raw label, and then we just bring in some kind of label. Label equals label. Set label, and then you get given the P1 score. Is this right? Excellent. So then the and then when it scores, we do like some kind of update score. So we need bar score. We need some kind of running score. This is going to be equal to 0. Score plus equals 1. Label dot text. Is it just called label dot text equals like the string of the score? Is that how it works? I don't know, but we're about to find out. Okay, so let's try and lose a point. I'm not surprised that didn't work, to be honest, because update score is never called. So here, area dot update score. Okay, does that work? Oh, didn't get out of the way. Boom. Wow. These aren't what I would really call centered. Incredible. And then we need like some sort of reset, right? Like, so, oh my goodness, why is there a space there? Let's have some kind of reset function that can, it resets the velocity. Yeah, wait, it's gonna be like some, what are you doing? I don't know. Yeah, so this is gonna be equal to, this is what we need. We need a constant, like, reset velocity, right? And that is going to be equal to this. And this is the reset velocity. We can define that, that's fine. So the reset velocity, we call reset velocity, current speed, reset speed. It's kind of a weird way to naming convention, like speed, velocity, but it is what it is. It is what it is. Reset speed. Basically just running that line of code again. And then position, we need to set the position. So we need like a reset pause. Yeah, what is this? That's an interesting question. Whereabouts is the middle? It's going to be the middle of the camera. Yeah, about here. How big is our camera? 560, 316. Position equals, wait, we haven't, wait, grab you, put you here, and set you to, what was it, like 580, 316, something like this. It's not that important. Don't overthink it. What? 300. That's fine. And then we call reset. So this will just immediately reset, right? I mean, if it works. Boom, boom, boom. Incredible. And I'm gonna have to actually win a point to test if this is working. Okay, well let's nerf the AI just to see if this is working. You should have like a like max speed or something like this, right? But let's actually just set it to 1 so we can win. We're testing negative. Wait, what is it? There we go. Okay, so now it should be beatable, right? It should actually be beatable because it's not quite fast enough. Theoretically, oh my goodness. There we go. So it always serves towards me. So instead of always serving to me, this recess weird. That's actually pretty fine, to be honest. We made Pong. Before you realize it, wow, let's turn the difficulty back up. We could make that like increase over time as well. Okay, can I actually beat this? I've made a creation that is more powerful than myself. Oh my goodness. It's doing the trick shots. Let's defensive mode. Doing a trick shot there. Oh, here we go. I think we need it to bounce, right? How do you actually win at Pong? Oh my goodness. So theoretically, over time, it's going to, oh my goodness. Theoretically, the ball will get faster than it's able to move, but I'm also capped at my speed of moving. But theoretically, I can play better. This is a big theory. Because I can predict where the ball is going to go, and so I won't be fooled by a bounce. So this AI, like if you want to beat the AI, it will chase after the ball and when it's going for a bounce. So the dream scenario is that I can be all the way. We found a bug. What happened there? That was totally bizarre. Am I ever going to be able to replicate that? I do not know. That's amazing. This is really cool. Wow. Okay. Well, let's make it. Let's make the ball just get a little bit. Wait, where's the like amount by which the ball? Here we go. So this is like ball speed creep, and that can be equal to like 1, right? So we can just make it get faster. The rate at which it's getting faster is now faster. So theoretically, okay, am I able to get a point on this guy? Oh, that was a good shot. Okay. Oh my goodness. Oh man, this is tough. It is beatable. It is definitely beatable. And it's, if we have a lot of angle, maybe we just need like a little bit more angle. So like there is, in the ball code, there's a divided by, where is it? This 10 here. Yeah, so this, like paddle, like angle, paddle, like hit angle proportion or something like this, right? Yeah, if we just like make it 8 or something like this, where was it? Here, yeah. So maybe let's just make it a bit more, we'll make it way more drastic just to make sure we're definitely looking at the right variable. Yeah, that's crazy. Okay, so then let's make it something like 6, I think, will probably be the sweet spot. Yeah, so this is quite dramatic now. Okay, so this should be winnable, right? Oh my goodness. Hey, we got a point and then failed to get back. Yes. Alright, misjudged. Okay, Skill issue, significant skill issue. So my speed is 9. I kind of want to just juice it a little bit. Okay, first to 5. This should be doable because it is going to get fooled by the bounce, and we are not fooled by the bounce. We have highly evolved brains, and yes, at a certain speed. Oh wow! Oh, okay. Well, looks like we're all gonna make mistakes. Isn't that nice that it kind of just goes for the? Yeah, look at that. Okay, if we need to hit bounce shots. Bounce shots are the only way that we're going to be able to win. There we go. Oh, that wasn't even the bounce that won. That is a perfect example of how it chases after the bounce to its own demise. We're not preventing. Oh my goodness. Oh, that, yeah, we really need to change that. 4-4. This is dramatic. Okay. Okay. Oh. And we lose. We have created a monster greater than ourselves. So that is, I would say, the first one ticked off of the 20 game challenge. So that is Pong. I hope you guys had fun. Yeah, I think that's it.